we will be making a project on fashion classifier. It will be a intermediate level project using TensorFlow, Keras, and its modules. So let's begin. So this is our channel. So please subscribe, like this video, and share it with your friends if you want them to make such good projects like you, and if you need to make a good impression on them. And this is our Instagram. You can follow us there. We upload daily videos there too. See, we have 37 followers, and this is the last video. So let's move on. First of all, what we need to do is we need to import TensorFlow. It is a library which we will use to make our model, and I import it as TF. I have just shortened the name from TensorFlow to TF. Now I need to import one more thing. For now, let's just move. We will see what's there. So I will restart and run all. So yeah, this will work. So it's importing. Let's just write importing the necessary module or library. Now what we need to do is, in the Keras there is a data set, a pre-processed data set called fashion means. So we need to load our data. So how we can do is, we need first of all train images comma train labels, and here the labels will be in the form of numbers from 0 to 9. Since our words can be biased, say I have labels in Hindi or English or in any other language, but numbers can't be biased towards one. So we need to import the test images too and test labels. So it is equals to tf.keras.datasets dot, its name is fashion means. Now we have loaded the data. So I think dot load underscore data. Now it's loaded and it will be stored in them. Now what we need to do is, we need to scale them, and we need to make the sizes as 28 by 28. So what I will do is, train images equals to, wait a minute, train underscore images upon, let's just take upon 225, and similarly with the test images, wait a minute, let me just do it. Yeah, now next step is we need to reshape them. So reshaping means that, say image is a very high, so I will compress the image to make it easy to use and fast to work on. So I will write train images dot reshape, and let's see 28 comma 28. Now similar thing with the test images, and we are ready to go. So let me just write importing the, wait a minute, data sets and reshaping and scaling them. So let's see, wait a minute, there is a problem, can't reshape array of. So I got the problem. We need to just specify the size too. So this will be 10,000, and I think it's okay. Let's see. Yeah, it's okay. Before moving, there is one more thing to add here. Since we will be using grayscale images, we need to add one that will decide the number of layers of colors. If we use 3 here, that means we will be using RGB, but we need to use the, you can say we are using the grayscale images, so we need to write here 1. So that's okay. So we have done everything almost. Now we need to create a model which will act like a brain for our program. Actually, in deep learning we use the term neurons, because in a neural network there will be a layer of neurons. So this one thing, this one circle is called a neuron, and they are arranged in a manner, and then this is first layer, this is second layer, this is third layer, but this one is input layer as it is written here, and this is the output layer, and all the other layers are hidden layers. They act similarly to our brain, where our brain find out the similarities between multiple things and try to recognize it through the similarities or the characteristics or the features. So to make that, we need to use tf.keras.sequential. It comes from the word sequence, and there are two ways to add deep layer. First one is using dot add method, where we indirectly add the method using the dot add in the model, and tf dot keras dot layers dot dense. So dense simply means that how many neurons you want, how many densely it must be. So we are simply using tens, since there will be 10 classifications here. There are 10 things in the images or the data set we are using. There will be pants, shirt, and top, and all of them consider of 10 things like that. So we can add like this, or what we can do is we can simply just write add square brackets and we can write tf.keras.layers.dense and we will be ready to go. So we need to add firstly the units, so you can just write units or you can simply write. So and the next thing what we want to add is activation. So this will be the formula or the specific pattern we will be using. So I will be first using the relu. So this is out of the video syllabus, but you can search on the YouTube. I will make a separate video for that too, so do not worry. And our input shape is, as you know, it's 28 times 28, 28 comma 28 comma 1, and we are ready to go. Now we need to compile it, we need to run it. So we need to add data on what we want to use it. So optimizer, first of all we need to specify the things we will be using. It's like a, you can say a sub part of a brain which will do all the processing part for us. So optimizer, as it is stated above, sorry I have a spelling mistake, no worries. Optimizer equals to, we will be using SGD here, that's sigmoid gradient descent. I have explained gradient descent in my earlier videos, so if you haven't learn about that, then kindly watch these videos, because they consist all the matter what's going on, how are they made, how will they work. So it's here for multiple features, this is there. And although single feature I have also explained, so no worries, let's move on. And we need to add a loss function too. So I think I have explained about loss functions too. So we will be using, here the sparse cross trophy. It's cross entropy, wait a minute, and it's here classification, no, it's categorical, categorial. So you do not need to remember them, you can just search on the Google what's the loss function for binary classification or multiple classifications, and you will find out that. Wait a minute, this is cross entropy, yeah. So this is compiled. Now we need to fit the data, so we will use model.fit. So we need to fit it data, so that will be train images comma train labels. So we have fit the labels and data. Now we need to specify the epochs, that's the how many time it should run, or how much effort should it make. That means that how much time it should run through the data, it should feed the data again and again. So I need to it to feed the data 10 times. So let's see how it well. So there is a problem, unknown loss function. Oh, okay, so let's see. So I got it, there will be a C here. So sometimes the spellings are a bit tough. So it is doing great, it started at accuracy of about 50%. Let's see, although there is one layer, so it wouldn't be much, so I will cancel it and add some more layers, so that there will be some more hidden layers and it will perform some better. Dot layers, wait a minute, layers dot dense units equal to, let's say we will be using 128 hidden layers, and the activation will be relu. And here we will be using softmax. Here softmax is nothing but activation function, so you need to not to worry. So I think, wait a minute, let's just put the these thing here, input shape, and we will be ready to go. So now let's fit it data. So now I think it's a bit faster, yeah, but it's not up to that standard, so it will take a lot of time, and more than a lot of time. Now it takes some time, so no worries. Let me just explain you one more thing, that we will, let me just put it here, yeah. So model dot evaluate is used to evaluate the our model on the test images and labels. So we will fit it test images and test labels. And now we need to predict. So model dot predict will tell us how well it is performing on the test set. So it will predict. And if we need to show the image, we can use the pie plot dot imshow to show us the image. So we need to import, that's matplot dot pyplot plot as plt. Wait a minute, there will be library, so it's a matplotlib dot pyplot as plt, and it's ready to go. Let it take some time, and its accuracy is stopped. So no worries, let's just cancel it out because it will take a lot of time and we do not have that much time. So it's done, almost everything is done. So I got an idea that what we can, another thing I want to tell is we can just flatten our data, so it's taking the images as a 2D data. So now I got the idea that why it was very slow, because we are not giving it a 1D data, we are giving it a 2D data. Let me just show you how I want to tell. So it's flatten TensorFlow, so this will show you how it does something. So wait a minute, so there is a 2D data and we need to flatten it. So this will put the first three like this, and then second row as like this, and this will just convert it from 2D to 1D. So this how you can save time and it will be easy to understand. So it's in layers dot flatten and it will do the thing. Now let's see if it works. So flatten, oh wait a minute, there is no r. Now it's ready to go. Let's see how it does. Oh wait a minute, I just put it in the wrong place, so it will be here. So now let's see, and let's shorten our epochs. So now let's see it, let it give some time, and there is a problem. So what's the problem? Let's see. Except for last dimension received labels dot shape. Okay, there is a problem. Logis dot shape, so it's the problem in the, so it's problem in labels dot shape. Okay, no worries. So I think I got the problem, I got the solution. I just by mistake put here images, but it must be labels. Now I think everything will be fine. So creating variable on a non first call to a function decorated with tf dot function. Yeah, there is the problem now. Invalid syntax. Okay, so we need to put a comma here, and I have specified the input shape above. Now it must work fine. So I got the problem. So last time we were not using the labels, so that's why our accuracy was very low. So that's why it's a bit fast now. So let's see how well it goes. So let's just take the epochs as 3 to make it a bit short, and let's see how much accuracy we can achieve. So I think if it achieves more than 80%, you all have to subscribe. So let's see, let's bet on that. I'm sure it will goes. So I think it will easily cross 80%. So let's bet for 85%. If it goes for 85%, you all will like, share and subscribe, and on the notification bell too. So let's see, that's a bet, and I will not be doing anything. This was my first try, that's final and all. So let's move on. So now let's plt dot im show, and we need to show our test images, and 0 here show specifies the position, and we need to give it a title. Plt dot, wait a minute, title test images, sorry I was doing the same mistake, labels and 0. So it will be okay, and I forgot that we need to write plt dot show at the last. So our accuracy is about wait a minute, it's about 84%. No worries, let's see, it will evaluate, and okay, there is no predict. Okay, I forgot predict, yeah. So it will work fine. So let's see. So our test accuracy is about 83% also, so that's good. So it is not showing, no worries. I think invalid shape for image data. Okay, so I need to do something. So what we can do is, it is having some problem in pyplot, so we can try using cv2, but the code is fine. Import cv2 and we can use that one. So no worries, we can use cv2 dot im show, and we need to give it a frame, so that will be our test images 0, and that will be fine. And cv2 dot wait key. Now let's see it, if it works fine or not. So I think it will work fine. No, cv2 is not so I need to restart all of them and run all, so it will work fine now. So it's done, and let's see what it does. So I think it will show. So it's showing error again, but this time it's imread, not imshow. Now let's see. It sometimes become hard to remember the syntax while working with multiple projects, so no worries. So Google Colab is not doing something, so let's try it in VS Code. I think that might work. So now let's run it in VS Code. I think it might run on this one. So it will be a fast training. So it will easily cross. So see, it shows us the number 9, and let me show you the things. So fashion, MNIST, labels. Now when we go there, I think it was boot only. So it was on official website. Let's see there. So it's ankle boot, right? So that's correct. So as you can see, our model is predicting well and it's working good. So that's the sequential. So in the next video, we will look at the convolution and pooling. So wait till the next video and see you later. And do not forget that we bet on the accuracy. So no cheating, and see you later.